In this video, we'll go back over outside and inside functions as another way to think about solving chain rule problems. Let's think about the example that we had before. The way we really ended up breaking this down was to think about what is the inside function here. And the way you want to think about this is you want to go in as far as you can to the function and take the most complicated thing you can that you know how to differentiate directly. So for instance, we see this in here. I can differentiate directly, and if I were to expand any further out, I then would not be able to, because then there's something like to the fifth outside, and that's something that requires a chain rule to solve. So you can try to break down these problems by starting from the inside and working your way out, where you sort of pick the most complicated thing and keep expanding from there. Another approach, and when I'm solving this, you do some combination of the two of these, is to start from the outside and work your way in. So this process would say, I see the example, I see something, something, something to the fifth, so I'm going to start with my outside function being u to the fifth. Well, what is u? Well, in this case, u ends up being x squared plus 3x plus 2, and that I can differentiate simply, so then I'm done to compile the chain rule directly here. This is something referred to as the sort of outside-inside rule, where the chain rule really says you differentiate the outside function, and plug in to that derivative the inside function, that is your f prime of u of x, and then you multiply by the derivative of the inside. Let's see what that might look like in application. So the derivative of g of x is tangent x plus 2x cubed plus 4x plus e to the x, all to the fifth power. Here we can just start. How do we differentiate tangent? That doesn't require anything fancy. That's a normal derivative. That's just secant squared. Plus, now this last part's where the chain rule comes into play. So I'm going to see my outside function as a u to the fifth again. And then this right here is my inside function. This becomes u. So what's my derivative here? Well, it's going to be 5u to the fourth, differentiating u to the fifth, times the derivative of the inside, which is a 6x squared plus 4 plus e to the x. And I can write this again, just plug my u in for that u, and that'll give me the answer. So g prime of x is going to be secant squared of x plus 5 times 2x cubed plus 4x plus e to the x, all to the fourth, times 6x squared plus 4 plus e to the x. That's the idea how looking at outside and inside functions or the outside-inside rule can help it be simpler to find the derivative of functions that are compositions using the chain rule.